Picture a farmer in 1780, no lab, no soil kit, no NPK chart. He kneels down, digs a fist into the earth, rolls it between his fingers, holds it up to the light, and then decides whether to plant wheat or walk away entirely. That decision was not a guess. It was the output of a diagnostic system refined over centuries, passed down through generations, and accurate enough to feed entire civilizations. The question is not how he did it. The question is why we stopped teaching it. For most of recorded agricultural history, there were no soil laboratories. The first systematic soil chemistry did not emerge until the 1840s with Justus von Liebig, and widespread soil testing did not reach ordinary farmers until the early 20th century. For the thousands of years before that, farmers across Europe, Asia, and the Americas developed their own field-based diagnostic systems, reading the land through texture, color, drainage behavior, and the plants that volunteered to grow there. This was not folklore. It was applied observation, and it worked. The foundation of the whole system was texture, and you learned it with your hands, not your eyes. The method is still taught today by agronomists like Manitoba specialist Mitchell Timmerman, who calls it reading the profile. You dig a pit, pull soil from different depths, wet it slightly, and work it between your thumb and fingers. Sand feels gritty and falls apart. Clay feels sticky, plastic, and holds its shape. Silt feels silky, almost floury. A skilled farmer could identify these in seconds, and that identification told him almost everything he needed to know about what the ground could hold. Here is where it gets specific, because old farmers were not guessing randomly. They had crop-to-soil matchmaking rules that modern agronomy has since confirmed. Heavy clay soils hold water and nutrients tightly, which makes them suitable for crops like rice and wheat that can tolerate wet, compact ground. Sandy soils drain fast and warm early in the season, making them better for groundnut and coconut, crops that will rot in waterlogged roots. And loamy soils, that balanced mix of sand, silt, and clay, were recognized across cultures as the best all-around growing medium. That knowledge predates chemistry by millennia. Color was the second diagnostic layer, and it carried a lot of information packed into a single glance. Dark brown or black topsoil signals high organic matter and strong structure, the kind of ground that holds moisture through a dry spell and releases nutrients steadily. Experienced farmers knew to trust the dark, but they also knew to watch for something more subtle, a gray or bluish tint deeper in the profile, which is a classic sign of prolonged waterlogging and oxygen starvation in the soil. That gray layer meant drainage problems, and planting into it without addressing it meant a failed crop. There was a third color signal that the most skilled readers watched for, and it is something modern soil scientists still use as a diagnostic today. It is called mottling. If you dig down 18 inches or so, and you see rusty orange or reddish spots scattered through a gray matrix, that is not random mineral variation. That is the fingerprint of a fluctuating water table. The iron in the soil is oxidizing and reducing in cycles as the water table rises and falls seasonally. Mottling at that depth tells you the ground floods periodically, which changes everything about what you can plant and when. Structure was the fourth reading, and this one required understanding what a healthy soil actually looks like when you break it apart. Good topsoil breaks into small, rounded aggregates, what agronomists call granular or crumb structure. Each little clump is a community of mineral particles bound together by organic matter and microbial activity. When you squeeze a handful of healthy topsoil and release it, it crumbles apart cleanly. Compacted or degraded soil does the opposite. It comes out in flat plates or a single dense mass, what soil science calls massive structure, and roots cannot penetrate it efficiently. Farmers learned to read this before anyone had a name for it. The fifth diagnostic was water behavior, and this was probably the fastest field test available. You pour water into a small depression in the soil, and you watch. Healthy soil with good aggregate structure infiltrates water quickly, pulling it down through the pore spaces. Degraded or compacted soil lets it sit, pool, and eventually run off sideways. The NRCS has confirmed that healthy soils infiltrate water faster and store significantly more of it for crops, which directly affects yield stability under both drought and heavy rainfall. But farmers were observing this same behavior long before the NRCS existed, and they used it to rank fields before they ever picked up a seed. Now here is where it gets genuinely impressive, because the best soil readers did not just use their hands and eyes. They used the plants that were already there. Certain plants volunteer in certain soil conditions, and experienced farmers learn to read that botanical vocabulary like a map. Rushes and sedges told you the water table was high and drainage was poor. Nettles often indicated high nitrogen and disturbed fertile ground. Certain mosses signaled acidity. Dock and plantain pointed toward compaction. This was not superstition, it was empirical pattern recognition built from generations of watching which plants showed up before the plow and what happened to the crops that followed. The earthworm count was another field expedient indicator that old farmers tracked informally and that modern soil health programs have since validated. When you turn a spade of soil and count what comes up, you are getting a rough biological census of that ground. A healthy, biologically active soil with good organic matter and structure supports a dense earthworm population. Compacted, depleted, or waterlogged soil does not. This is not a precise measurement, but it is a directional one, and directional information is exactly what a farmer making a planting decision needs. The old ways worked for a reason. Let me show you why that reason is still valid today. Understanding what has been lost matters here because it reframes why this skill was so critical. Research published in major sustainable agriculture texts has documented that many cultivated soils have lost between 40 and 60% of their original organic matter since they were first plowed, primarily through intensive tillage and bare fallows. That loss shows up directly in a field reading. Thinner, dark topsoil, weaker crumb structure, slower water infiltration, fewer earthworms. The soil profile tells the story of what has been done to the land. And a farmer who could read that profile could also read whether the land was improving or declining under their management. A 2023 study of 13 organic farmers in Yolo County, California, found something that should not be surprising, but somehow still is. These experienced farmers relied heavily on sensory, field-based soil knowledge. They dug, they felt, they visually inspected their soils regularly, they watched crop performance patterns across seasons, and they noticed changes over time. They were doing with modern vocabulary and a scientific framework behind them almost exactly what farmers had been doing for centuries. The diagnostic loop, dig, feel, observe, match to crop had not changed. Only the language around it had. The full diagnostic sequence, when you lay it out as a process, is elegant in its simplicity. You start at the surface, reading color and structure. You dig down to at least 18 inches and look for how the profile changes with depth. You check for mottling, gray layers, and the depth at which roots can actually penetrate. You pour water and watch infiltration rate. You check organic matter depth by how far the dark color extends. And then you cross-reference all of that against what plants are volunteering on the edges of the field. That is your soil report, and you ran it with a spade and your own two hands. What made this system genuinely powerful was that it was cumulative. A single reading gave you a snapshot. A decade of readings on the same land gave you a dynamic picture of whether your management was building the soil or depleting it. Farmers who practiced this consistently were essentially running a long-term soil health monitoring program without any of the infrastructure we associate with that phrase today. They knew which fields were improving under cover crops and rotation, and which were declining under repeated bare tillage. That feedback loop is what allowed traditional agriculture in some regions to sustain productivity for hundreds of years on the same ground. There is a reason this knowledge got deprioritized, and it is worth naming directly. When soil testing kits and laboratory analysis became widely available in the 20th century, the institutional message was that the old field methods were imprecise and the lab was more reliable. That is partially true. A lab test gives you specific numbers, but it also created a generation of farmers who trusted the paper over the pit, who stopped digging and feeling and watching, and who lost the ability to catch problems between test cycles. They solved this centuries ago. The question is why we forgot, and the answer is that precision tools sometimes make people stop paying attention. The practical value for anyone working land today is real and immediate. You do not need a lab to know whether a field has drainage problems, whether your topsoil is building or declining, or whether a plot is likely to waterlog in a wet spring. A shovel, 20 minutes, and the diagnostic framework in this video gets you most of the way there. And if your results ever disagree with a lab report, that is worth investigating, because the profile is telling you something about spatial variation and real-time conditions that a grab sample sent to a lab cannot fully capture. The two approaches are not competitors, they are complements, and the field reading is the one you can do anytime you want. What strikes me every time I go back through the historical record on this is how complete the system was. Texture, color, structure, drainage, indicator plants, water behavior, earthworm density. Each one a separate data channel, each one telling you something the others cannot. And the whole thing was teachable by demonstration, learnable by practice, and free to run. No subscription, no shipping time, no waiting on results. Just a spade, a trained eye, and the patience to actually look at what the ground is telling you. That is the kind of knowledge that does not go out of date. If this is the kind of knowledge you want more of, the channel is full of it. We have covered passive heating systems that kept stone buildings warm through Scandinavian winters, field expedient building techniques that modern codes quietly retired, and wartime survival engineering that still holds up as practical method. Hit subscribe if you want to keep digging into the stuff that actually worked and the reasons it worked. And if you have a specific technique or forgotten skill you want us to pull out of the archive, drop it in the comments. That is where most of our best episodes start.